So in terms of the directories that are made, it's going to make the directory that is going to be related to the sample that you're working with and the coverage that you've selected. Um, and it's going to just do like a directory create to make that. And it's going to put the full path to where your output is going to be. And then it's going to load the unfiltered BSseq object, which we had specified over here. So that's going to be your unfiltered. So it's going to be the argument plus the input file that you're using. And read RDS is the command you use to read .rds files. So like for each of these different commands, the different ways. So read.csv is specifically for CSVs. I think read.xl is specifically for Excel, but that's from a specific package. I think read.rds is in base R. So it's like R when you download and install R, it just comes with R. That's what I mean when I say base R. And then filtered, so this is mainly creating the output. It's going to code filtered underscore BSseq RDS, and then we just replace it here. So the file is going to be filtered. So it's going to be BSseq filter the CpGs, and then BS is going to be equal to the unfiltered BSseq object that you already read in. And then the coverage is going to be based on the arguments that you already specified, how much coverage you want. And then the per sample is going to be this one, also based on the arguments that you specified. So very similar to what Charles has here on the filtering step. It's just that I think I took into consideration the full full function. That's why I added all these other steps. And then core regions. So your regions is going to use the function get region. I think BS is so the BS object initially was referring to the unfiltered object, but now the BS object is going to refer to the filtered object.
Okay.
Does that make sense?
Yeah.
So the output from this command is just basically going to be your BS, your new BS object. So that's why it's just going to be BS. Yeah. So that filtered version is going to be used to identify your regions, and then the next important file is the regions text file. Or is it the regions totals? Okay. I mean, I'll double check.
PDF of that.
Yeah. So you get a regions text file. Let me just double check what it looks like. Two filter regions text file. No. Oh, one filter regions. Okay, this one is too big. It might open, it might not. So this is important, not that important. I don't usually look at this until like the end, because some of the information from this region text file is also just combined into another file that we're going to look at when we're doing annotations. I mainly look at the we don't need to look at. But anyway, basically, I don't know why. It's very difficult to read this without the rainbow CSV colors. Let me open with. All right. Let me just double check if my. All right, it's there. Yeah, I don't know why it's not working with this text file. Anyway.
But the regions, is it's telling you the different regions of like the methylation site, CPU clusters.
Yeah.
Like
So.
Spaces in between.
Yeah, I just wanted to go over through it quickly. I thought I would get a nice.
The color coding.
Yeah, but it's okay. But the regions txt file has all your regions and information that will be used to make plots. So the next plots that we're going to make, all right, so for each of the regions you have, you're going to have a region ID assigned to it. Ooh. that's the wrong plot.
Yeah.
That's the wrong plot. So yeah, and you need the just regions txt, the one underneath that.
Oh.
Yeah. And then you just say open anyway. So for each of the regions you have a region ID assigned to it, and then you're gonna have the chromosome, the start, and then the end. So this is the end of that region, and then you're gonna have the width, how many base pairs you have for that region, and then you're gonna have n being the number of CpGs in that region, and then you have the minimum coverage you have, and then the mean coverage, standard deviation based on coverage, and then mean methylation standard deviation too. So all this information is going to be added onto an Excel file.
Okay. Yeah, it said it was too large of a file.
Yeah, it's okay. But yeah, usually I don't open this until later on. So next, you're gonna have plot regions. So in line with Charles's like stuff, so that we're on the same page too. So basically, get regions is gonna help you make those regions, and then plot region stats, plot regions SD plots is gonna help you make these plots. I guess my code is gonna get to that soon. So yeah, so it's gonna basically take. So you see how we have the regions here. The output from that is gonna be your list of regions now, and then that's what you're gonna use to make a regions plot PDF. And then the same thing is you're gonna use it to make the standard deviation plots based on the regions. And then next we're gonna compute region totals txt. This one is the important file, so we're gonna try and open that one. This one is the next file that you need to look at. So for this one, you're also gonna have coverage, the minimum coverage, the methylation standard deviation for that coverage, the total amount of regions per thousands, like how many thousand regions you have there, the total width in megabase pairs, and the, I don't know what n underscore m means really. What I usually look at for this, at least what's important for the next part, is looking at the coverage mean and the methylation standard deviation.
Okay.
So those are the next parts that are important. So usually for this part, for regions, what we're trying to go is you're trying to make sure that the standard deviation you have is above 0.05. That's the first thing. And then you're trying to target having around 500,000 regions. That's the other thing, because that's making it computationally like not as intensive. And then the final thing is you want it to be as high as possible using that criteria. So for example, so we can clearly see like at 4x at 0.05 we're about 1 million regions, because this is per thousand, right? So if it's like one, it's supposed to be 1 million. Although it's very weird to read 1 million like this, but it is 1 million regions. So this is 900,000, 600,000, 400,000, 33,000. So for 4x, we can see we have about 1 million regions. 4x at 0.05 standard deviation. That's what we have. So I'll probably go for like a higher thing. Let's see, 8x, 10x, 12x, 14, 15. This project had pretty good coverage. Usually I don't really go this far. I usually go like up until 10x, and yeah, or have reached 500,000 regions. But so yeah, we're seeing even at 20x. So what I'll usually do is probably I'll just go for 20x at 0.07.
Okay.
Because that's still above. Because you can also do like 20x 600,000 regions, but it might crash because it's computationally intensive. So your job might like crash, and then it'll give you an error. Or you can just go for that 20 at 0.07. So the reason why we try and get a higher standard deviation more than 0.05 is to try and capture the most variable regions, hoping that those variable regions would help make a better network.
Okay.
But yeah, so
can you analyze just like one region at a time, or just like you just select the ones that like you think will be the best?
sorry.
Like for each like these regions that we get, you're just picking the one that has like the ideal like standard deviation and the
Yeah.
coverage, and then or maybe a couple others.
So by doing this, you're already subsetting a set of regions.
Okay. Yeah.
So I think I don't remember. So let's just say for the CpGs, we started with let's go back to CpG. So we started with let's just say 3x at 0.75, and that gave us 25 million CpGs, right? And then from those 25 million CpGs, you're gonna group them into regions, and then those regions are going to be, let's see, are going to reach a number of regions in total, like a total number of like clusters that you were able to group. Yeah. So a minimum of 3 CpGs together, not separated more than 100 base pairs, are going to be used to make your regions. And then you use the regions total. So I think in total, so for example, for this, so the total number of K regions is, I guess, 2 million regions in total. So you have 2 million regions in total. And from that subset, you know that some of those are going to have poor coverage. So you're just going to subset the ones that have a high coverage and that have a standard deviation that's high enough to be able to capture something interesting. So usually, this works out most of the time. Okay. The way we're doing it now. Okay. I think the thing is, you could just go directly and try and do like a network without doing the subsetting of regions. I think it's still theoretically possible. It's just that computationally intensive. Yeah. Because that's a lot of regions, and some of the regions don't have coverage anyway, like good coverage anyway. So. So that's why we do what we do. And then going back to Charles's tutorial, I don't think I had. So these plots in the code are going to be, let's see, regions totals, regions plot, photo regions. Okay. I'm just trying to see what I have. I don't know if I have it here. Because basically what this PDF is, okay, regions plots. Okay, yeah, this is the one. So the regions plots is going to look like this. Alright, so this is the same thing that Charles has. And just opening a larger version of it here. It's going to have the width. The red line is like the median. Yeah. Okay. And then it's going to have the width on average for those different regions you have, the number of CpGs you have, the mean coverage, the average mean in terms of the coverage, the methylation mean, and the methylation standard deviation for all those regions that you have. And then I think, yeah, these SD plots, I don't clearly get them, so I will not try and explain, but they explain something to do with the standard deviation. Okay, yeah. Also to do with the number of CpGs, the mean coverage, the methylation mean, and so on and so forth. Okay. But I don't usually look at them. And then this is the other plot that's made, the regions totals PDF. Basically, you're trying to capture as much as like the standard deviation that's high enough. So at 0.5 would be where we're giving the cutoff, and I don't know what he used specifically, but let's see if we can. Regions totals. Yeah, I guess for this, at least the other project that we're using as an example, there was just good coverage that we don't have. You see how everything is towards like A lot of it has a lot of coverage, even at 0.05 when you're comparing it to this. Like this is more spread out. Whereas for this project, it has most of it is squeezed in together, meaning the coverage is like pretty good for most of these, which was good for that project. So usually for the CpG totals, this is what I look at, and I try and align the total CpGs as well as the total number of regions that are going to be included in the analysis, and then I usually add this plot if I'm doing a presentation, like an oral presentation instead of a poster.
Okay.
But yeah, I think usually for your presentation, you might just need to explain what the Comethyl is and move on to the results and spend more time getting the results.
Yeah,
but you could have the methods as a supplement in case someone was willing to ask specific questions about the methods of how you got stuff.
Yeah.
So that's that. And then let's see. All right, I was explaining O1 script. So yeah, so basically this is what we're going to get from the script. And then once it's done, it'll tell you some information about the project route, what was the input, the coverage, the per sample, and the things that you already set. And then it'll also give you the time. And then it'll also give an output of the parameters that you use, text file. And it'll just save those lines. So that's the second script. So let's see if the stuff that we were waiting for is done. Let's go. Okay. Ready to go. Okay. So, all right. So we're gonna try and run. All right. So we're gonna go on the test data set. All right. So I'm gonna try and run some of the stuff that I already explained. So this is going to be change directory. So every time you want to run Pixie, you need to make sure you're in the directory where your Pixie is.
Okay.
I guess one thing that we didn't test is if you would be able to do this. Let's see. All right, we'll run some scripts. Let's run script 1 and 2 and see what we get. But I think I already explained some of that for the test data set. And then we'll troubleshoot the environment and see if you can use it.
Okay.
Because I think the idea would be if you're able to try out this on your own on the test data set and see if it works.
Yeah, with the test data set.
Yeah.
Yeah, I think so.
Yeah.
I think they're good.
So that'll be good if we're able to do it. So let's see. Pixie 1. Alright, so because this is a smaller data set, this should be like boom, 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 I think. But, yeah, as slow as. Alright, test. Alright, this is correct. Okay. Oh, wait a minute. Let me just stop it over there. What I didn't do is I didn't double check the data folder.
Okay.
All right, let me also just cancel. Just cancel like data. Don't need that. This jobs thing. Don't need it. So this is going to be status reports. Okay. ls, and then it's wc-l. Okay, so 173. Okay, so let me just go back to the Pixie directory. Okay, actually, I'll try and do an S batch for this. Let's see. All right, so I am running. Oh, oh no.
Oh.
We got an error. So. Yeah, let me just double check something and see. Yeah, I'm getting this wrong. Metadata. This looks wise to me. All right. Because we didn't get any errors with the first one that we ran. I ought to test data gives errors like this. All right. Yeah, we're going to give it another go and see. Oh, nice. Okay. Yeah, it doesn't make sense why. Unless if I don't think I deleted the test data by mistake, right? Alright, let me troubleshoot this with AI. Because this is very weird. Because I don't know why it's not working when it was working for the full data set. Oh, one of them is empty? Damn. Guess read table. Alright, let me. Ah. Yeah, so one of our files is not having any sample.
Just one.
Yeah. So basically, I don't know why. Let me just double check the original data. So this is sample number 4030. Yeah, 4030. Let me double check the original data. Oh, sorry. Let me ls just the CpG reports. Makes it easier to read. Alright, so all of them see there's something. Alright, let me sort them. Well, this is not very much sorted. But why is okay, let me that's called ls the 4030 sample. Okay. Alright. Yeah, I don't know why. So what needs to happen is we need to regenerate the test dataset.
Okay.
But maybe for sample number 30. I think I can do that.
Just for the one sample.
Yeah, because it's like, let me read the error again. No lines available input. Error in read table called by guess Bismark file type. Yeah. Alright. Yeah, okay, cool. Let's see. Where was I doing this? Alright. So alright. Oh, okay. I know what I can do. Let's yeah. So sometimes in bioinformatics, trying to do something, stuff doesn't work out. I never expected to get this error. Sample IDs. I'm just going to delete all of these and then I'm just going to add one sample ID, 4030. So it's either it got corrupted as it was making as it was making that file, or there's no information on chromosome 22 for that file. I want to think it's the first one.
Okay.
I don't think, yeah. So, alright, let's make mini data. Scripts. Alright, one sample. Alright, yes. Alright. Alright, let me see if the original run is going through as planned. Okay, that's done. Alright. Yeah, so the first script is just made one thing. And then okay, cool. Let me double check if this file worked. Processed size reports. Let's do ls star 4030 star, and then okay, that didn't work as intended. 430 dash a. Okay, cool, nice. All right, let's run this. Let's go. All right. Oh. Right, so this is what happens when you try to run stuff and you're not in the Pixie folder.
Okay.
You
change the directory.
Yeah. So basically, the Pixie folder is it's gonna have this Pixie Tomo file, and this Tomo file has a list of other software packages that are supposed to run with your code. If that makes sense. Yeah. So just gonna change to that folder. So yeah, you see how you have this Pixie Tomo file and Pixie log file? Yeah. So, all right. All right, so I guess this first run might take like 5 minutes if all goes well and there's no error, which they shouldn't. But let me just see now, because I think we had discussed the scripts number 1, 2, 3. All right, 3. Oh, 02. 02 is mostly now just dealing with. Let me do this. So 02 is dealing with filtering regions based on the standard deviation that you would have selected, and then it's also going to make remake the region's plots by just the filtered one instead of so like on Charles's tutorial, you're going to filter the regions using the coverage and the standard deviation. You went for 10x and 0.05, and then you're going to have a filtered regions plot, which is going to be like this. So that's what 02 is doing. And then in terms of additional arguments, so the project root argument is going to be the same. The input regions is going to be it's going to be coming from the text file, the regions text file, because the regions text file is being used as input regions because each region has its own assigned region ID, like region 1, 2, 3, 4, 5. And then you're going to have minimum coverage that you're going to use. Let's see, O2. All right, so here we chose minimum 4x coverage at 0.08. And then the standard deviation. And then these base size, bins, max Q, and width and height, these are all to do with the plot that's related to the filtered and unfiltered regions. So because there was some issues with this filtered regions plot, sometimes it has gaps in it, and it's like a misfunction within the R. I don't know why. I decided to remake it into like a combined plot that has both the filtered and unfiltered before and after.
Okay.
I can show a better illustration of it with the actual plot. Okay, let's see. I'm seeing some outputs over there. Let's go. All right, cool. So first script is done. Because it's smaller, again, faster to troubleshoot. So like, I think we can run, let's see, Pixie run, okay. So let's just be looking at things step by step. What time is it now? Okay. Actually, okay, we'll run this script. Okay, let me just double check what coverage you're going to get for this. And then we'll just stop after the script. And then we'll see if we can get you to run it on your laptop with your login, if we're lucky. Or we need to troubleshoot some more. So tests, Comethyl output. Alright, so this is going to be the outputs that we have. So if we're using a coverage of 0.03, at 0.75, that's going to cover 1/30 of all samples, and the 490,000 CpGs.
Okay.
Because this is number of CpGs per million CpGs.
Okay.
So basically that's what we're going to run, and then we're going to see. Alright, it's loading. Yeah, so for most of these scripts, they should take like 5 to 10 minutes, really. It doesn't take that long. But what takes long is reading in the packages.
Yeah.
So like for each time it reads in, so for example, at the top here, it's reading in these packages. So that's what probably takes a minute or so. But so like now it's telling you what it's gonna do. So you see how we say it's gonna be like 497,000 methylation loci. So that's the same number we get here. So yeah. So the filtering step is done. It has filtered those CpGs, 173 samples. So now it's just saving this filtered BSseq object. I think that's pretty much it for this script. I don't think there's, let me just double check if there's anything else to it. Oh, okay. And then I guess it's gonna plot the regions. Oh, okay. Alright, yeah. That doesn't take a lot of time. At least if you have it on a small number of samples. All right, so now that's done. So the benefits, again, of a small test data set is quick feedback. We know our code is working. And so usually if you're working on the Visual Studio Code, you just have to press the refresh button, and then outputs are going to be there.
Okay.
So it's going to have us the region plots, and then region totals, and then regions txt. This is the next file that we look at. So I think I'll just stop the recording here, and then we'll see if you can run it. Like if you can run this environment, or you need to do something.
Okay.
Let's see, what time is it? 5. Okay. I will stop the video.